Hello everyone. In this lesson, we continue to discuss the behavior of a function as x increases without bound, either in positive direction or negative direction. Here are a couple of facts that we will be using. The limit as x approaches positive infinity of e to the x equals positive infinity, and the limit as x approaches negative infinity, e to the x is equal to 0. Limit as x approaches positive infinity of e to the negative x equals 0. And the limit as x approaches negative infinity of e to the x equals positive infinity. Now we can also think about these sets of limits by imagining the graph of e to the x. You notice it starts like really low from the left side, going towards positive infinity. There's an asymptote at 0 right there. And as it goes to the right, passes through 0, 1, and then it goes up. For negative infinity, for e is equal to negative x, it is actually the reverse of that. It's like the graph of e to the x reflected through the y-axis. So it's a different kind of orientation. It starts high and then ends low on the right. The asymptote at y equals 0. We're also going to talk about radicals. And here are some facts that you need to know. Absolute value of x is equal to the square root of x squared for all x. Absolute value of x is equal to x when x is greater than 0. The absolute value of x is equal to negative x when x is less than 0. So let's look at some examples. Concerning radicals, we apply division by factoring out the square root of the highest degree of x in the denominator while using limit laws to solve. Again, if your square root function is in the numerator, it will be logical to factor out your highest degree wherever the square root function is. Okay? But for this case, let us factor out the square roots of the highest degree in the denominator. So we are going to evaluate both the limit of the function as x approaches positive infinity and the limit of the function as x approaches negative infinity. So considering this function, f of x is equal to 3x minus 2 over square root 4x squared plus 5. Solving this problem, f of x is equal to 3x minus 2 over radical 4x squared plus 5. Notice here our highest degree of x in the denominator is x squared, but because it has a square root sign, we're thinking about the square root of x squared. Now, the square root of x squared is equal to absolute value of x. So then we will divide each term by the absolute value of x, or in the same way, we'll multiply by 1 over absolute value of x. So dividing by absolute value of x or multiplying by 1 over the absolute value of x, we're actually doing the same thing. Okay, so here's how we're going to write it. We're going to write limit as x approaches infinity of 3x minus 2 over the square root of 4x squared plus 5 equals the limit as x approaches infinity of 1 over radical x times 3x minus 2 over 1 over radical x times square root of 4x squared plus 5. In this case, since x is positive, we think of one of the rules that we know, that when x is positive, the absolute value of x is equal to x. Okay, so we write, instead of 1 over absolute value of x, because we know x is positive, we just write 1 over x, both the numerator and the denominator. And then we distribute this 1 over x all the way through. So we end up with limit as x approaches infinity, 3 minus 2 over x over the square root of the 1 over x. If we're multiplying through the radical sign, we bring it inside, it becomes the square root of 1 over x squared, right? And then multiply that by 4x squared plus 5 times 1 over x squared. And then we try to simplify that algebraically. So that becomes the limit as x approaches infinity, 3 minus 2 over x over the square root of 4 plus 5 over x squared. And notice what is happening as x approaches infinity. The 2 over x will be going off to 0. 5 over x squared will be going off to 0. So we are left with 3 over radical 4, because these two parts went off to 0. So that will be 3 over 2. When x approaches negative infinity, our 1 over radical x, not radical x, or 1 over absolute value of x be equal to 1 over negative x. And multiply this 1 over negative x by the numerator and the denominator. And so we have 1 over negative x, 3x minus 2. So 1 over negative x, the square root of 4x squared plus 5. Then we try to simplify this. Comes negative 3 minus 2 over x all over the square root of 4x squared and the square root 1 over x squared. Reason being, this becomes 1 over x squared because negative x times negative x is positive x squared times 1 over x squared. And then that will be equal to x, the limit as x approaches infinity, negative 3 plus 2 over x approaches 0, and then over 4, square root of 4 plus 5 over x squared, and 5 over x squared approaches 0. So that will become equal to negative 3 over radical 4. And the final answer will be negative 3/2. Do some examples with transcendentals, and these will include functions like our trigonometric functions and our exponential functions and so on. We are familiar with the end behavior of many of these transcendentals. We know sine of x oscillates between 1 and negative 1. So there's really no asymptote in this case. But for e to the x, we know that e to the x approaches 0 as x approaches negative infinity, and it approaches positive infinity as x approaches positive infinity, whilst e to the negative x is just a flip of that over the y-axis, so it will approach positive infinity as x approaches negative infinity, and 0 as x approaches positive infinity. Okay, so now we're asked to evaluate the limit as x approaches positive infinity of 1 plus e to the negative x. We'll also evaluate limit as x approaches negative infinity as well. So let's do both of them. So for the question that we asked initially, the limit as x approaches positive infinity of 1 over 1 plus e to the negative x. So notice then as e to the negative x approaches, as e to the negative x goes to positive infinity, and what is happening to the graph is that as x approaches positive infinity, as x approaches positive infinity, then the function e to the negative x approaches 0. So then we'll replace this 0 here. And so we have 1 over 1 plus 0. That's 1 over 1 equals 1. So your limit as x approaches positive infinity of 1 over 1 plus e to the negative x equals 1. And this is like one of our logistic functions that we'll come across, or that we have come across earlier. The next part, limit as x approaches negative infinity of 1 over 1 plus e to the negative x. As x approaches negative infinity, e to the negative x will be approaching positive infinity. So then this becomes equal to 1 over infinity. And so our final answer will be equal to 0. More algebra, evaluate limit as x approaches negative infinity of 5 e to the x plus 2 e to the negative x all over e to the x plus 3 e to the negative x, and the limit as x approaches positive infinity of the same function. Then this will involve a little bit more algebra, but the idea is still the same. We have to divide by the highest power because it's looking like this function that's more rational, I guess. And so we're looking at dividing by the highest. It's a transcendental. It's actually a transcendental function, all right? So just one transcendental over the other. And so this is what we will do here, is that we'll factor out our e to the negative x, because this is our quote-unquote higher one as we go into negative infinity. So the direction in absolute value, the negative x will be considered higher. So we are factoring out this case. It's the same effect as if we've divided each part by e to the negative x. Okay, this is just a different way of writing the same thing. Remember, previously when we wrote 1 over the stuff, now we're factoring out the stuff, and earlier we just divided by the stuff that we consider the highest. Okay, so that's going to be equal to e to the negative x factored out in each case. And then we're going to be plugging in or seeing what each of these will be. So 5 e to the 2x will approach 0, e to the 2x will approach 0. So you're left with our final answers 2/3. And for approaching positive infinity, here obviously the higher one will be e to the x, e to the positive x. So then we factor out that, and so we are left with 5 plus e to the negative 2x over 1 plus 3e to the negative x. So our answer will be 5 over 1, because these other parts will be going to 0. So our final answer will be 5. Find f of x equals sine of x, the limit as x approaches positive infinity. We'll have enough time to do this first part of that f of x and then identify any asymptotes. That -1 is less than or equal to sine of x, less than or equal to positive 1. Remember that we said that by the oscillation. So if we divide through each part by x, and then take the limits, what you'll find is a limit as x approaches positive infinity of -1 over x goes to 0. Limit as x approaches positive infinity of 1 over x equals 0. So by the squeeze theorem, the limit as x approaches positive infinity of sine of x over x is equal to 0 by the squeeze theorem. Therefore, your horizontal asymptote there would be y equals 0. Thank you very much. And